Hello, everybody. Welcome to section 3.2. We're moving away, believe it or not, from increasing, decreasing, positive, negative, all of that. Now, don't get me wrong. You're still going to have to know how to do all of those things to actually graphing these things on our own paper. Okay, so today we're going to talk about graphing quadratic inequalities, section 3.2. The essential questions we need to think about today: how do you graph quadratic inequalities? What does the greater than mean for the graph? What does the less than mean for the graph? What would the equal to on the bottom of those do to the graph? And how do I sketch these on a sheet of paper? First things first, I'm a realist. No, first things first, let's go to our first note card for the lesson, note card 74. Guys, remember, if you haven't been keeping up with note cards, now's your time to start fresh. Let's get Unit 3 going strong, okay? You're going to write all of this down, and then this little purple box in the bottom corner can go on the back of your note card. It basically is this top stuff, just written in a more condensed form. You need to have all of this, but that little purple box is just quick and to the point. So pause me and finish up note card 74. Okay, so with note card 74, we know that if you have a less than or a less than or equal to, you're going to shade below. But if you have just the less than, it's going to be a dotted line. And if you have a less than or equal to, it's going to be a solid line. I was going to say shaded, but solid line. Okay, if you have a greater than or a greater than or equal to, you're going to shade above. And if you just have the greater than, it's going to be a dotted line. And if you have the greater than or equal to, it's going to be a solid line. When determining the shade, you're going to use a test point. All of this I'm going to explain when we do an example or 2 or 3 or 4. All right, next note card 75. These are the steps to sketch on your paper. You are going to be sketching on your paper today, all right? So you need to know the steps that are required. Yes, there are 9 steps. It's Miss Sharp. I'm going to be detailed and thorough. It's one of the things I love about math is being meticulous. So pause me and get these steps written down. All right, welcome back. I'm going to go in and add this little box to this step slide just because I want to have it there. All right, so before you go and start sketching these things, they're going to look like that. Before you do that, all of this needs to happen. You need to know the vertex. You need to write down at least one set of corresponding points. We need to talk about what I mean there. Corresponding points have the same y value, so it's going to be these points that mirror each other on each side of the axis of symmetry, okay? You need that so you can determine how wide the parabola is. Then you're going to go, oh, in the rules from my note card 74, is it going to be dotted or solid? Oh, in my rules from note card 74, am I going to shade above or below? And then you decide, okay, with those points that you got from step 1 and step 2, what axes do I need? Okay, how do I need to draw these axes? How far out do I need to go? Do I need to go all the way from negative 10 to 10, all the way from negative 10 to 10, or not? Plot your points and then draw your parabola and shade. So I'm going to quickly scroll through the next 4 slides, and then we're going to get to note card 76 where we do examples together. So here is an example of graphing y is less than 5x squared minus 3x plus 2, and it's a dotted line because it has the less than, and it's shaded below because it's a less than. And notice the dotted line and it's shaded below. That's what it's going to end up looking like. Now your graph's not going to be as pretty as this one because it was computer generated. That's okay. Look at this one. It's y greater than. So it's going to be dotted because it has a greater than, not an equal to on it. And you're going to shade above. And so in this one, the above is right here inside of the parabola. All right, greater than or equal to, well, that's going to be a solid line, and this one happens to open down, so a solid line and shaded above. So those of you that try to be, your brains are really robotic, you're going to be like, oh, why is this one shaded outside the parabola and not inside? Notice, I'm never going to say outside and inside. I don't use that verbiage. The verbiage I use is you shade above or below, okay? So that one's shaded above because it's a greater than. And then look at this one. This one's a less than. It's dotted right here. and it's shaded below. Okay. Okay, so here we are on to note card 76, where we are doing examples of a less than, which is going to be a dotted line and shaded below. Now on your note card, we're going to have two graphs, one to go with this and one to go with this. Yeah, yes, they both have a less than. But this one opens up and this one opens down, and I want you to get used to the feel of that. So if you want to do this example on the front of note card 76 and this one on the back, great. If you want to just take your note card and just do one on the left side and one on the right side, that's fine too. But I need both of these on this note card. Okay, so you'll need to either use your calculator or Desmos to plot this so you can get the vertex and a set of corresponding points. I went ahead and plotted it. Here it is. And I have the vertex is 3, -3. So you need to jot that down on a piece of paper. Now I want to get two key points that aren't nasty like this. Okay, so if I go right here, right at the right spot, I get 2, -1, and then I get, it's not like it, 4, -1. See, I knew that this has a slope of 2, and we have not talked about that, but that A is 2. So what that means is from the vertex, I'm going to go up to right 1 and up to left 1. So I'm going to go, I know you can't see this. Let's see if I can move this. Oh, I can. Okay. So I'm going to go right here and put y equals -1 as a line here, which you got to move me back over. Oh, goodness. Okay. Oh, goodness. Okay, so I drew that in just so I could get these points so you could see that that's a set of corresponding points. Now I could use these x-intercepts, they're just ugly and I don't like them, so I didn't want to use them. So anyway, I'm going to use my corresponding points as 2, -1 and 4, -1, and I'm jotting that down. You need to jot that down. All right, now back to the slides. See, we're getting ready to have to do this on our own sheet of paper, all right? So you need to follow the steps in note card 75. I wrote down the vertex. I wrote down corresponding points. I need to determine if the parabola is solid or dotted and when will I shade above or below. All right, so this is dotted and I will shade below. I already have that up there. I kind of have a cheat sheet for you, but that will be something that you need to do on your own when I don't have it already there for you. All right, the next thing is I need to neatly sketch my X and Y axes to fit the ordered pairs that I got from steps 1 and 2, and then go from there. All right, so I'm going to switch over to my document camera so you can see how I'm going to proceed with this problem. Now, not all of you have graph paper, and I get it, but if you do, you can get it. If you're in the classroom, I've got a whole bin of these little pieces of paper. They're little. They're little. I'm making it look big because I've got the document camera right here. And you could use that, or you could use your graph paper. If you use a big sheet of graph paper, you're going to want to get a ruler and create your axes where you want them, okay? But I do want you to know that you don't have to have this graph paper, okay? If you do, it makes your life easier, but let's just say you don't. All right, so I know that my vertex is at 3, -3. My corresponding points are 2, -1 and 4, -1. And so let me think about it. My vertex is 3, -3. That's in the fourth quadrant, and these are also in the fourth quadrant. So when I say determine the axes that you need, or where you want the axes, I'm really looking at the fourth quadrant. I don't even need to go, goodness, why did I do that? I don't even need to go that high up. So I call this a quick graph, trying to figure out where I need to look at. And I'm really looking in the fourth quadrant mostly. Let me move my face over. Okay, so I go to plot the points. Now, if you're doing it freehand like this, you need to be careful. Try to keep your tick marks the same distance apart. So 3, -3, go right here, put my dot. That's my vertex. And this one opened up, so that's good to know. 2, -1, and 4, -1. So I've got my little reindeer here, okay? And then I just do my best, and it's not going to be perfect because I'm not using a computer, and I'm sketching it. However, I wasn't supposed to sketch it solid. So I wanted to show you that a lot of students will do that because they're getting used to sketching, but we need to do a dotted line. Now, if you need to draw the solid line and then erase little parts of it, that's fine, but this is a dotted line. And then back to the actual problem, it is shaded below. So I take this and I'm going to shade below. Now, the way I like to think about it, it was a y less than, so I want to shade the part of the parabola. I always look above it or below of the vertex. I look above or below the vertex. This was a shaded below because it was a less than, so I'm going to shade down here, which is all outside of the parabola. Fun times. Now, if you had this, of course, it'd be nicer and neater and great, but I know not all of you do. So you can do it like this, and this will suffice. You do need to have the points labeled. This is 3, -3. This is 4, -1. And this is 2, -1. So yes, those of you that are asking, can you just go on Desmos and take a screenshot? No, you have got to be able to graph these on your own. Now, I did want to show you that if I go to Desmos and I go in the front of this y less than, it will do it for me. Take this. It will. But guys, you got to keep in mind that you're going to be doing things on the SAT and ACT that you don't get a calculator for. And guys, when I did this, look, it has some nice points for me. It was wonderful. But you can check yourself this way, and that's great. But you still have got to be able to do it on your own sheet of paper. So I am going to have you on tonight's assignment to do it on your own sheet of paper and upload your paper. I know, fun, right? Okay, so all of that just for this example right here. So now I want you to pause me and I want you to work through finding the vertex, finding corresponding points, and all of that for this inequality. Okay, so I've put the inequality into Desmos. I have. It's wonderful. And remember, I can find the vertex by hand, -b/2a. I can do all of this by hand. I can use my graphing calculator as well, but I'm okay with you using Desmos. Just got to get these points right. So we have that the vertex is 2, 2. I'm jotting that on my piece of paper. You'll see that in a minute. And then I can use these x-intercepts, not ideal. This has a -3 in the front. If you look over at the inequality, it has a -3. So that means from the vertex, you're going to go down 3 to the right one and down 3 to the left one. So I know that right here, I can't get straight at 1. Yeah, I can. 1, -1, and then it'll be 3, -1. Okay, so my corresponding points are 1, -1, and 3, -1. My pencil lid keeps breaking. All right, so again, that's because that A is -3. So from my vertex, I'm going to go down 3, right 1, down 3, left 1, and I can get those corresponding points. Nice, pretty corresponding points. It's dotted and it's shaded below. So using this information that I have, vertex and corresponding points. Also, I can look at Desmos. I know that I'm in the first and the fourth quadrants. So to do my quick graph, I'm going to do this. I'm going to go 2, 2, 1, -1, 3. Oops, see, I went off a little bit too far there. That's okay. I'm just going to be careful. 3, -1. It's a dotted parabola because it's a less than. Okay, and I will shade below the vertex. So it's either going to be outside of the parabola or inside. If I look at the vertex and below, it's got to be right here. Now, I haven't talked about finding a point and testing a point, but I'm going to do that here in a minute. But pause me and finish up your note card. Okay, so let's talk about testing a point. So back if you look up here at note card 74, when determining where to shade, if that's a little confusing for you, you can pick a test point and see if it satisfies the quadratic inequality. If it does, then that part needs to be shaded. So let's look at this. I like to use 0, 0 as my test point. Here's my graph, 0, 0. If I plug 0 in, I'd have 0 less than 15. Is 0 less than 15? Yes. And so this is where 0, 0 would be, and I would shade all of that part of the around the parabola. Okay, so let's try 0, 0 here. 0 less than negative 10. That's not true. So 0, 0 is right here. That will not be shaded, so I would have to shade inside the parabola. All right, so note card 77, we're going to look at dotted lines again, but shading above. I want you to write these down, get the vertex, find your corresponding points, and I'll be back. Now I actually want to work this one without looking at Desmos. And so remember, to find the vertex, you do negative b over 2a. So that would be negative 2 over 2 times 1. So I get the x value of my vertex is negative 1. And then I plug it back in. Now I'm pretending there's an equal sign here. So y would be, let's see, that would be 1 minus 2 plus 1. So that would actually be 0. So my vertex is negative 1, 0. Okay, now the slope of this is 1. So, and this is opening up. So from my vertex of negative 1, 0, I know that I'm going to go up 1, right 1, and up 1, left 1. This is a dotted line. And it's a greater than, so I'm going to shade above. Now, testing the points, I like to pick the point 0, 0. If I go right here, is 0 greater than 1? Because those will go away. Is 0 greater than 1? No. So wherever 0, 0 is shouldn't be shaded, and it's not, so I'm good to go. Guys, I can't remember if I gave you time to finish up note card 76. So there we go. There's note card 76. Two examples really of a dotted line shaded below. Just one's opening up and one's opening down. All right. Oh, so pause me if you need to. All right, so here we go on note card 77. I just went over this one. Now I want to go over this one. I have, oh goodness. I have started the work on finding the vertex by hand because this is super important that you know how to do this. Negative b over 2a, I get that the x value of the vertex is 2. I plug it back in. There's a negative out front, so I'm super careful. It's going to be negative 4 plus 8 minus 7, which gives me negative 3. So my vertex is 2, negative 3. Now I know it's opening down. And this right here, this a, is negative 1. So that means from the point to negative 3, I'm going to go down 1 to the right 1 and down 1 to the left 1. I'm going to show you, without writing down the corresponding points yet, I'll show you how I do that and figure out the corresponding points. So I've got 2, negative 3 as the vertex. I know that's the maximum because this opens down. I'm going to go ahead and label it. And because A was negative 1, like I said, from here I'm going to go down 1. Okay, so down to negative 4 here to the left 1. And then back up to the vertex, down 1 to the right 1. So these ordered pairs, this one is 3, negative 4, and this one is 1, negative 4. Now, this is a dotted line because it's a greater than. There it is. And then it's a greater than, so I'm going to shade above. Now, you don't have to sit here and shade extensively. That'll suffice. That's good enough. Check your point 0, 0. If I plug it in right here, I'd have 0 is greater than negative 7, which is very true. So we need that to be shaded, and it is. Fun. Let's look at this one. Let's look at this one in Desmos. So I typed this one in Desmos. There is my vertex that we got, 2, negative 3. There's actually, I could find another set of corresponding points, but we used 1, negative 4. Goodness, that's right here, which again, can't get right. If you're careful, there it is. 1, negative 4 and 3, negative 4. There it is. But yeah, I just wanted to show you that was shaded above, it was dotted. I can confirm that on Desmos, but I'm still going to have to be able to do it by hand. All right, so if you haven't yet, pause me and finish up your note card 77. All right, so here's note card 78. We're going to be looking at solid lines now. So this is a less than or equal to. And so it's going to be solid and shaded below. So pause me and get yourself set up. Okay, so the first one that we're going to do for this note card is y is less than or equal to x squared minus 4x. So let's do the calculations to find the vertex by hand. X equals negative b over 2a. So negative 4 over 2 times 1 is going to give me 4 over 2. And I get 2 for the x coordinate of my vertex. Then I plug that in. 4 minus 8, and I get negative 4. So my vertex is 2, negative 4. Now, a is 1, so I'm opening up, and my initial slope is 1. So I'm going to go to the point 2, negative 4. And then from that point, because a is 1, I go up 1 to the left 1, and I go up 1 to the right 1. And notice, I'm just adding tick marks when I need them. So this is 3, negative 3, and this one is, oh goodness, I always run to that. I'm going to just put that ordered pair right here because I have to label them. This one is 1, negative 3. It's a solid line, and it's a less than or equal to, so I would shade outside or below it. Now let's check the point 0. 0, 0. 0 less than or equal to 0, yes. So that 0, 0, it needs to be shaded, and it is. Now, I do recommend when it's close and iffy, because if I'm not careful, I might have drawn that a little wider and I wouldn't have known. So putting this in a Desmos to check yourself is always a good thing, or your calculator. Of course, Desmos is easier. Now, you can't see it, but let me move my screen over. I'm getting ready to type this in. So y less than or equal to x squared minus 4x. Okay, so here it is. And honestly, yeah, I was not that careful. I should have been more careful. So I have 2, negative 4, and then I had the point 1, negative 3 right there. Oh, goodness. And the point 3, negative 3 right there. And it does hit actually at 0 and 4. So I need to go back and make sure I have that right. And the way I got away with it is I had the equal to on it, but I'm going to go back here and make sure that when it happens like that, that I'm careful. So that x-intercept is another set of corresponding points that is important here. There we go. I feel a little bit better now. Okay. There we go. Now the point 0, 0 is not the best test point for this one because it actually lies on the parabola. So maybe pick the point, let's try the point 2, 0 right here. So if I want to use that as my test point, I plug it in. Is 0 less than or equal to, let's see, 2 squared is 4 minus, I'm plugging 2 in, so 4, negative 4. Is 0 less than or equal to negative 4? No, so it should not be shaded there. All right, so I plopped that image in here so you guys could see. Pause me if you want to. Go ahead and finish this example on the note card, and we're going to get to this other one. So go ahead and pause me and finish that if you'd like, or you can wait. Now this one is y is less than or equal to negative x squared plus 9. Y'all, that's just the parent function reflected over the x-axis and shifted up 9, so it's going to be upside down. But I wanted to go over this part of it. To find the vertex, y'all, b is 0. There's no x term. So your x value is 0, you plug it back in and you get 9. So we know that we are opening down and our vertex is actually on the y-axis. All right, so 0, 9 is my vertex. Now, A is -1. So from this point, I'm going to go down 1, right 1, and down 1, left 1. The little tick marks that I need here, like that. And then it's a solid line. And it actually hits at -3 and 3. Those are my x-intercepts. Okay, now it's solid because it has the equal to, and it's shaded below, so this would be it. Now your test point of 0, 0, if I plug 0 in up here, is 0 less than or equal to 9? Yes, it is. So we are correct. Now I'm going to label my corresponding points, 1, 8, and -1, 8. I use this thin lead now because I think it's fun, but then it breaks all the time. Anyway. And just so you can see it, this is it in Desmos. We had our vertex at 0, 9. Yikes, -1, 8, and 1, 8. And yes, my x-intercepts were -3 and 3. I knew that because there was no b term, and taking the square root of 9 would be 3 and 3. But anyway, there we go. Pause me and finish up this note card. We have one more note card to go. Pause me. All right, so here's the last note card 79. These are solid lines and they're shaded above. So pause me and go ahead and get these going. Okay, so I went ahead and worked out the first one. Negative b over 2a, I got the x value is 4, and then you plug it back in and get the y value of 2. So I knew the vertex was 4, 2. I knew that a was positive 1, so it was opening up. So then I went up 1 to the right 1, up 1 to the left 1, and I got 3, 3, and 5, 3 as my corresponding points. It's a solid line, and it's shaded above. Now the second one I want to actually work out with you and talk through. Y is greater than or equal to -x squared minus 6x minus 4. All right, so I did the work here, and I just want to point out that I messed up. I had to be really careful here, and I double checked myself. So negative b over 2a, so -6 over 2 times -1, and that would be 6 over -2, which is -3. Then, when I've got to go put the -3 back in, there's already a negative out front here, so that sits there. And then I have a -3 squared minus 6 times -3 minus 4. Here's where the order of operations comes in play that you learned a long, long time ago, okay? So you keep that negative out front and you do this exponent. -3 squared, or -3 times -3, is a positive 9, but there's already a negative out front. So this first term turns into a -9. And then this will be a plus 18 and a minus 4. So it turns out to be 9 minus 4, which is 5. So your vertex is -3, 5. It opens down because A is negative. So I'm in the second quadrant. -3. Taking my time. Don't have to be perfect, but taking my time. Okay, so there's my vertex, -3, 5. Okay, now my corresponding point, it's opening down and A is -1. So I go down 1 to the right 1. And if I'm not a neat drawer, I have a hard time with this. You're going to have a hard time with this. That's -2, 4. And then I got to go this way. So down 1, left 1. Ah, that's -4, 4. All right, it's a solid line. Now, where is it going to cross the x-axis? I might need to be careful here. I need to go and put this in a Desmos as well. I think I already have. I think. Yeah. Okay, so here it is in Desmos. And we can double check our vertex. Yes, we got that right. Now, I got corresponding points on when I showed it to you as 4, -4, and -2. No, not 4, -4. I said that wrong. -4, 4, and -2, 2, 4. All right, so this crosses the x-axis at ugly places. So it actually doesn't go through the origin, so I'm okay. Just to make sure when I go to draw the graph, I don't show it going through the origin. And then I keep it to the left of the origin. So there we go. Okay, so there it is. It's a solid line. It's a greater than. So I'm going to shade above it like that. My test point would be 0, 0. Plug it in here. 0 greater than or equal to -4. Yes, it is. So we're good to go. Again, here's Desmos, and you can check yourself that way. And here's our graph. All right, so now I've plopped it back in here for you so you can finish up your note card 79. I know that was a very long 30-minute video to explain this, but I just want to make sure you're crystal clear. I hope you have a great day. Bye, guys. Oh, don't forget to upload your note cards on your note card presentation. Y'all, get those slides going. If you're someone that's not been doing that, you need to change your habits now so you can have better grades. Because this is just taking notes, okay? So get your note card presentations, your images loaded on there and get your presentation ready. Reversing the order makes it easier. Some of you haven't done that. I'm not sure why. I've asked you to. I put it on the working document. I talked about it in class. I don't know what to do. I just don't know. But get your note cards going. Bye, guys.